Introduction to LinkedHashMap in Java. Introduction to maps in Java. Hello, everyone. We're going to look at different implementation of the map interface. And for map interface, there are other implementations such as HashMap, TreeMap, and our focus for today will be LinkedHashMap. Each implementation has its unique features. HashMap is known for its speed. TreeMap is known for being able to sort its keys, and LinkedHashMap combines hash table efficiency with a linked list to maintain insertion order. Purpose of LinkedHashMap. So the LinkedHashMap is designed specifically to maintain the order of elements as they are inserted, which is something HashMap doesn't offer. And this feature makes LinkedHashMap particularly useful in scenarios where the order of data is important. So example could be caching mechanism or maintaining a predictable iteration order. Here's a code snippet to show how you can create LinkedHashMap and add items in there and iterate. Characteristics of LinkedHashMap. So LinkedHashMap maintains a doubly linked list. By maintaining a doubly linked list, it makes it possible to retrieve elements in the order they were inserted without sacrificing the performance benefits of hashing. The operations like get, put, and remove have a time complexity of 1 under typical condition, which is incredibly efficient. Internal working of LinkedHashMap. So internally, LinkedHashMap uses an entry class that extends HashMap entry. And this class includes 2 additional references for the next and previous entries in the list, and this enables the order maintenance. And there are also 2 modes of order available. Insertion order, which is the default you have, and access order, which can be enabled through the constructor. And access order, what it does is rearranges entries based on their last exit. So insertion order mode, which the entries in the map appears in the exact order they were added. But in access order mode, the map reorders these entries each time they are accessed, which is particularly useful if you are designing like caches, least recently used caches. And feel free to take a look at reference to learn more about these different order mode. Practical use cases of LinkedHashMap. So one common use of LinkedHashMap is in the implementation of caches, where it is important to remove the oldest accessed item, such as in memory management scenarios. And another use would be if you have an application that requires a predictable iteration order. Here are real examples of linked hash map uses. So let's think about a web service that logs users' access. Then you can use a linked hash map to store this data. And by doing that, you allow the service to easily retrieve or display the most recent accesses in the exact order they occurred. Another example would be handling HTTP requests, where maintaining the order of parameters can be important for processing. Code demonstration, basic operation. So you can see that you can create a linked hash map and add entries by calling put method, and also take a look at how iteration over the map entries will display items in the order they were added unless access order is specified. Try running this example, and when access order is set to true, accessing an item will move it to the end of the list. It demonstrates its dynamic reordering. Code demonstration implementing a simple cache. So we talked about LRU cache as an example. So here is a simple example. What you want to do is you want to use access order mode. So you want to set this to be true to automatically move the most recently accessed items to the end of the list. And when the cache reaches capacity, the oldest entry can be removed first. So it demonstrates efficient cache management. Best practices for using linked hash map. So linked hash map is ideal when you need the performance of a hash map, but also care about the order of entries. But it's important to consider the memory overhead due to the maintenance of a linked list in addition to the hash table. So choose linked hash map only if maintaining order is necessary. Otherwise, a regular hash map might be more memory efficient. Thank you everyone for listening.